Bismillahirrahmanirrahim and Assalamualaikum and a very good afternoon. So as promised, today is basically the last or final week of this semester. Therefore, I would like to wrap up some examples and guidelines for your final exam. Okay, first thing, let's look at the final exam format for Discourse, Signal and Systems. So you'll be given 5 questions to be answered in 2.5 hours, and you just need to answer only 4 questions. Okay, only 4 questions need to be answered, but there are 2 parts, which are the part A and part B, and part A consists of 3 questions and it is compulsory section. Okay, you need to answer all 3 questions. Okay, no options in part A, so you have to answer all 3 questions. Okay, so the instruction will be stated clearly on top of the question set in part A. Right, so what are the 3 questions? Okay, what are the topics involved? So for question 1, it is from chapter 1, the introduction to signal and systems, both in analog and discrete signal. Okay, so this is you have in time domain and also in n domain, the discrete signal. Okay, so for those who have problems in discrete time signal, so please make sure you do lots of exercises to make sure you can score in this particular question. So each question contribute 25 marks. Okay, so 25 marks for each question. All right, so the second question, also a compulsory one, is from chapter 5 and 6. Okay, chapter 5 is the transfer function and plot, and chapter 6 from filter design and analysis. Okay, so either the question begins with filter analysis followed by transfer function, or the other way around. Okay, again, question 2 is compulsory. You must answer question 1 and 2. And also question 3. Question 3 is from chapter 2, Fourier series. Okay, so you need to make sure you master the first 2 chapters, followed by chapter 5 and 6 that had never been asked in the test before. Alright, next you have part 2 or part B. In this part, you have 2 questions. You will be given 2 questions. Okay, but you only need to answer 1. Okay, you need to choose either question 4 or question 5. Or if you have time, you can answer both if you want, but only 1 mark will be considered, either from question 4 or question 5. Okay, what are the topics covered in question 4 and 5? So question 4 basically will be covering chapter 3, Fourier transform, and chapter 4 in question 5, it is the Laplace transform. Okay, so you need to choose either to answer Fourier transform or Laplace transform. So altogether, 4 questions need to be answered within 2.5 hours. Please make sure you write down the question number properly in your answer script. Let's have a look at examples of past year's question. I just want to show you how the final exam question looks like. So each of the questions contribute 25 marks. Okay, so the rest other examples will be uploaded later in the e-learning. All right, so part A, again, you need to answer all 3 questions. Okay, example part A, question 1 from chapter 1. So this is from chapter 1, in which you have intro into signal and system. So meaning that you need to master the signal operation. So what's involved in here? You need to sketch the signal or write equation either in unit step function, ramp function, and so on. Okay, next you should be able to perform signal operation and system classification. Okay, system classification, either it is linear, memory, memoryless, causal, okay, and so on. And also the end domain, okay, the discrete signal. Okay, just as your first test. Let's look at the example. Okay, as mentioned, clearly stated on top of the question, part A, you need to answer all 3 questions. Okay, question 1, 2, and 3. Right, so for question 1, chapter 1, determine, please make sure you read these statements carefully and highlight important keywords or important questions. Okay, sometimes in one sentence you have 2 or more than 1 question to be answered. Okay, so the first one, determine whether this system are memory or memoryless. So this is the first question you need to answer. Okay, based on the following, you have 2 sub questions. So you need to determine either this equation is memory or memoryless, and also the second one. Right, so how to prove or how to show whether it's memory or memoryless? First, you need to have steps. So how to identify whether it's memory or memoryless? So you need to test the given equation with t. For example, when t equal to 0, so you replace y0 equal to 4 plus sine 0 x0. So then you need to identify, is there any, is it only current state or involve previous and next states? Okay, so then you can decide whether the system is memory or memoryless. Okay, same goes to other system, linearity, causal. Okay, so basic thing, you need to know the definitions of the system plus the equation involved. Okay, so you need to have this in mind, right? Same goes to the second question. So you need to decide whether it's memory or memoryless, then justify. How to justify? By you showing the steps, then you can justify your answer. Okay, that's the first question, meaning that first you need to answer memory or memoryless. Secondly, justify your answer based on your steps. Third, discuss the difference between memory and memoryless system. Fourth, state example for each system. Okay, so discuss the difference between memory and memoryless. So that's why you need to know the definitions. So if you need to do comparison, so better use compare them in a table, or you can just write a statement and state example. Okay, so example, if you refer back to our discussion in system classification, so for memory and memoryless, that's example. Okay, for example, V equal to ITR. So this is an example of memory system, and the other equation for memoryless system. So memoryless, it cannot remember anything. So memory, it remembers something else rather than the current state. Okay, in question 1b, so you have a figure Q1b continuous system and given the input as x1 and x2. Okay, the first question, illustrate graphically, meaning you need to sketch three signals, x1, x2, and yt. So what is x1? x1 is from here, and then x2, and then yt after the operation. So in this case, obviously, yt equal to, this is the summation. So x1t plus, okay, the summation representing plus, but please make sure you check every single sign. Okay, in this case, you'll notice that x2t, but if you notice here, you have negative belongs to x2. So x negative x2t. So this is equal to x1t minus x2t. Okay, so but the question asks you to sketch. Okay, please do not leave your answer in equation only, but this one, the equation will be counted as your steps and it will be given marks, but then the final answer should be in sketching. Okay, next, signal yt undergoes differentiation. Write the signal representation in terms of unit step function. Okay, how the unit step function equation looks like, something like this when you have u, and u. Okay, that's unit step function. And impulse function when you have delta t. Okay, either it being delayed or not, depends. Okay, plus or negative t naught. Okay, sorry, this is supposed to be delta. Okay, and then describe zt. So based on your sketching, so the second question asks you to illustrate graphically based on your sketching. So describe what type of signal you have in zt. Okay, so make sure you address all questions carefully. Next, part C will be in discrete. So when it is in n domain, so it is a discrete signal. So your signals should look something like this. Okay, this is your n, a whole number, 1, 2, 3, and so on. It can be both sides, positive or negative. Okay, this is the n domain. So again, the question asks you to illustrate graphically. So you need to sketch signal xn. Okay, so xn equal to del n. So this is del n. Okay, this is, so you have del n plus minus 0. So this is at del n. And then you have n minus 1. So please make sure you remember when that's shifting. So you need to compare with basic equation 1 over 2 del n minus positive 1. So the signal be shifted to the right by 1. Right, so followed by the other components. Right, and then analyze both signal at point A and point B. Okay, so this is point A and point B. So you need to do signal operation. And then sketch, okay, analyze, meaning that you need to present the signals in mathematical expression. Then you need to sketch the signal. That's why the marks is 6, okay, because you need to represent lots of equations and sketching. And the third part, if Rn, okay, if the signal Rn is then multiplied with signal Sn, okay, determine Zn, okay, again another signal operation, right? And then lastly, determine whether the system is stable or causal. Okay, so you need to perform the system classification and please justify although the question didn't ask you to justify, you need to justify. Sometimes your answer, causal or non-causal, only 1 mark, but here is 2 marks, so better you include your justification for another 1 mark. For example, you said causal, then state why. Move on to the second question. In part A, still a compulsory question. You must answer this question. So this is from chapter 5, transfer function and bot plot, and also chapter 6, the filter design and analysis. Right, given a transfer function, so obviously this is from chapter 5. Alright, given the transfer function, illustrate graphically magnitude and phase plot of the transfer function. Okay, so in this case, you need to perform, you need to sketch your bot plot. So what you need to do before you plot a bot plot? So first, you need to represent this into a standard form. So how the standard form looks like? Okay, if you still remember, the standard form should have the constant, and then you have the S equation, and all S must only be added by 1. So in this case, you have 2 S over 2 plus 1 divided by, and then at the bottom you can see you can factorize this one into S plus 2 S plus 4. Okay, and then complete the standard form. So you have constant 2 on top, and on the other side the S function, so S over 2 plus must be added by 1, and at the bottom you have 2 components, so another 2 from here, so S over 2 plus 1, and another one you have 4 S over 4 plus 1. Okay, so this is in standard form. Okay, but not yet answering the question because you need to illustrate graphically. So what you need to do next is to represent the individual transfer function. So start with, you have the first one, the constant, and then on top you have zeros at 2, not at origin, and then the third one you have poles at 2, and you have another one poles at 4. Okay, so then you need to plot, you need to write, okay, first write individual transfer function. So I call it HXS, X depending on your number, and then sketch individual HXS both in magnitude and phase. Okay, so once you have the individual transfer function, then you need to sum them up, both the magnitude and the phase, right? So that's why you got 8 marks here, right? So how to sketch the bot plot, I have discussed this in chapter 5, so please try again. Okay, plotting the bot plot. Okay, you don't need to use the semi-log graph paper, just sketch in your answer script. Okay, based on your sketching, okay, once you have sketched individual, meaning that this is in the same plot or using the same axis, okay, and then you sum them up, sum the magnitude and sum the theta as well, okay, the phase. Right, once you have summed the signal, then you may see the shape of the filter. So then you can answer sub-question 2. Okay, state types of filter you have from the first plot. And next is question part B. Okay, this is the filter analysis from chapter 6. So when you have frequency response, this is called frequency response, so you can identify what types of filter it is. So it's flat top, so obviously it is Butterworth, and then you can write down the parameters. Okay, so here you have alpha p and then alpha s, and please take note with the unit as well. Okay, in this case it uses frequency in hertz. If you want to convert it into omega, so you need to multiply with 2 pi, so omega in radian per second. All right, so this is your omega p, and this is your omega s. Right, so types of filter and justify your answer. Okay, so obviously this is Butterworth filter, and because it is flat top. Okay, flat top at passband area. This is your passband area. And then is it low pass or high pass? So obviously in this shape it is a low pass filter. So it is a Butterworth because you have flat top samples or no ripples, and then it is a low pass because only low frequency component will be chosen. All right, and then minimum passband gain. So from the parameters you have identified earlier, so you can write down what's the value of the alpha p and alpha s, and also omega p and omega s. Okay, please make sure you look at the notation carefully. Okay, in here you have f, but in the question you need to give your answer in omega, so obviously you need to multiply the frequency with 2 pi to get the omega values. Right, and then calculate the minimum order number, filter order number. So you know it is Butterworth, so you need to refer to the appendix for filter characteristics. So refer to an equation for Butterworth. Okay, and then cutoff frequency. So obviously only 2 marks. Okay, remember in chapter 6 to decide omega c for Butterworth filter is a bit challenging, but only 2 marks given here. Why? Because it's quite straightforward. If you look at the graph, so omega c usually happen at minus 3 dB value. So obviously you have the minus 3 dB here. So obviously your omega c will be more or less at the same position as your omega p. But again, this is 40 Hertz. The question asks you omega c. So omega c equals to 2 pi of your fc. So 2 pi multiplied with 40, right? And then normalized transfer function. So refer to the filter characteristics for Butterworth again. So write down the normalized transfer function, look at the equation, and obviously in the normalized transfer function we'll be having the polynomials or coefficients. Or coefficients. So you need to refer to the table based on your n. Okay, so don't forget in n you need to round your answer to the next higher whole number. Okay, for example, if you got n equal to 2.4, so obviously your n will be 3. So to write the normalized transfer function, we should consider n equal to 3, not 2 or 2.4. Right? Once you have your normalized transfer function, then you can convert it into actual transfer function by referring to the transformation table. Transformation. Okay, so in this case, your S from the normalized transfer function will be converted into new equation. For example, S over omega C and so on, depending on types of filter you have, right? So finally, output of the filter, if the input of the filter is given as xt. So what you need to do, so you have this graph. So now you need to sketch this signal inside here. Okay, so here you have the frequency given in pi. So it's already been calculated in omega. So you can divide it to pi 15, to pi 200 for example, and then here is to pi 500. And here is to pi 1. Okay, so you plot the signal inside this graph. So look at which component will be in and which component will be out of the range. Okay, so the maximum frequency accepted is 200, obviously up to this point. So meaning that this component, the higher frequency component, will be outside the graph and it will be removed from the system. Okay, and the question asks you for the output yt, meaning that you need to write the equation. If the question asks you sketch, then you need to sketch. Okay, move on to the third compulsory question, question 3. So this is from Fourier series, chapter 2, Fourier series. Okay, so in Fourier series, you need to know the conversion sine to cosine. Okay, when you have both sine and cosine sharing the same frequency plus cos tan t, so you need to perform or simplify the equation using equivalent equation. If you still remember, an cos omega and t, and how about the theta equal to inverse tangent of whatever. Okay, so please make sure you do some revision for chapter 2, okay, just as your first test. Alright, so you need to be able to sketch as well. So from the given equation in sine and cosine, so you should be able to sketch single-sided spectrum. Single-sided. Okay, if it mentions spectrum, meaning that the signal in frequency domain. Okay, this is the spectrum. Okay, either it is single-sided or double-sided. Okay, single-sided for sine and cosine, or it is also called trigonometric. Okay, and for double-sided, it is in exponential form. Alright, so illustrate graphically the impulse train. So this is impulse train pt. So in time domain. Okay, so in time domain, it should be single-sided spectrum, and then express cosine Fourier series up to only one harmonics. Okay, express PT. What is PT? Okay, so PT represented by this impulse train. So how to know the equation? So obviously in Fourier series, once you have the signal, then you need to use the Fourier coefficients table. Fourier coefficients table to get the equation in exponential function. Okay, so pt equal to c naught plus the summation of cn ej and omega t. Okay, so please refer back to this exponential function. Once you have the exponential function, then you can convert this into trigonometric form. Alright, and then obtain the mathematical expression of yt, so sum operation, and then utilize. Okay, stated clearly, you need to use trigonometric identity. Okay, why? Because the input here in cosine, xt is in cosine. So the impulse train here may be in sine or cosine function. When you multiply them, then it will involve the equation may be in sine and cosine shape. So you need to use the identity, trigonometric identity, to simplify the equation. Okay, next, illustrate graphically single-sided magnitude spectrum. Okay, so based on here, so xt already in cosine, so obviously it is in single-sided spectrum. Only magnitude, so you don't have to sketch the face. And yt, so yt after the operations, or from this equation, you can illustrate the signal in terms of its spectrum. Okay, not in time domain, but in frequency domain, because it is spectrum. And then compare both in Q3A4 in here, explain how they are different. Okay, so you need to compare xt, the spectrum xt versus yt. So what can you say about the spectrum? Okay, next part, sub question B in question 3. So is the application of Fourier series. Usually it will be in circuit analysis. So you need to determine the voltage zt. So obviously you need to use voltage divider, and you need to be careful in Fourier series, because if you look at the input yt, you have more than one frequency component. So we can call this is omega 1, and then omega 2, and omega 3. Okay, so if you represent the equation, so zt will be equal to yt multiply with the c component in Fourier series 1 over j omega and c, okay, divided by the total impedance, so r plus 1 over j omega and c. Okay, so what is omega and c? So you need to calculate your z based on different omega. So meaning that, so zt will be equal to z1t plus z2t plus z3t. So what is z1t? So z1t is the calculation when you use omega 1. Okay, when you use omega 1 in yt and omega 1 in omega n here and here. Okay, so and then z2 when you use omega 2 in yt and also in omega n, and z3 when you use omega 3 in your calculation. Okay, finally you sum them up. Right, next, illustrate graphically the double-sided magnitude spectrum. Okay, the double-sided spectrum. Okay, once you have the equation in exponential form, okay, let's look at, okay, the question in part 1 asks you to write the exponential form. Okay, so given in cosine in trigonometric form, so once you have your equation in trigonometric form, and then you need to convert them into exponential form, then you have completed in part 1. Okay, in part 2, once you have the exponential form, then you can sketch double-sided spectrum of signal yt and zt. Okay, yt is the input and zt is the output, meaning that you need to convert yt into exponential form and then your zt in exponential form. So you have two graphs here. right? So next, obtain the average power of ZT, the output signal. So, but remember Parseval's theorem. So once we have the double-sided magnitude spectrum, so you can calculate the average power by having a summation of the amplitude of the spectrum. Okay, spectrum component. So C0 squared plus Cn squared. So n depending on how many frequencies you have, how many components you have. Okay. So by using Parseval's theorem, so you can estimate the average power by the summation of the magnitude squared of individual components in your spectrum, right, such as the functionality of processing block in figure Q3b. Okay, so usually when you have a circuit analysis in Fourier series, it will be either a filter. Okay, usually a filter. Is it low pass or high pass? Okay, so based on your spectrum, you can decide whether it's a low pass or high pass filter. And usually, if you still remember in modulation application, modulation and demodulation, we will be using low pass filter at the end to detect the original signal back. So I will expect that this circuit representing the low pass filter. Finish with part A, in which you need to answer all three questions. Okay, move on to part B, in which you will be given two questions, question 4 and 5. So you need to decide either to answer question 4 or question 5. Okay, so question 4 will be from chapter 3, Fourier transform. And question 5 from chapter 4, Laplace transform. Okay, so I will recommend you to look at both questions. Okay, look at the difficulty level and look at the mark distribution. So which one? Sometimes the question may look a bit longer, but it has lots of sub questions with lower marks. Okay, it will be safer to answer that types of question rather than answering just one or two sub questions but with bigger marks portion. Okay, so because if you answer that type of question with bigger mark allocation, so if you miss one or two steps at the beginning, so your final answer may be wrong. Okay, so you may be penalized because of the mistakes. Right, if you answer with smaller marks allocation, so if you miss the first step, then you can still score for the next following sub questions. Right, this is example of question in question 4 in part B. So you need to compare either to the difficulty level of question 4 and question 5. So question 4 is from chapter 3, Fourier transform. Okay, so read through the question. So obviously in Fourier transform, you need to be able to do operations and then refer to Fourier transform table for the properties. Okay, and here, okay, you can see the signal change, okay, duality, so all about property. So you make sure you refer to Fourier transform table in order to perform the operations, okay, in frequency domain. The same goes to question for C and D. So this is differentiation in Fourier transform. So again, refer to Fourier transform table. And part D is the application of Fourier transform. again a filter, so you can revise back the modulation, demodulation, the filter part, so you should be able to answer the application question. Okay, this is question 5 from chapter 4, the Laplace transform. So I will not discuss in details for question 4 and 5 because I think I have discussed a lot. I have been given lots of examples for question 4 chapter 3 and 4. So please revise back because mostly it involves the property. So you need to refer to tables, Fourier transform table or Laplace transform table in order to solve this kind of question. Okay, this is another Laplace transform properties. Okay, there's operation involved. So you just need to convert everything in S domain. So Laplace transform in S domain. Okay, and then you have the operation in S domain. Okay, for example, if you look at here, so in T domain at this point, in T domain it will be ET convolve with FT. But in S domain, it will be ES multiply with FS. Okay, all about signal operation. Okay, and then HS, so represented by the dash box. Okay, and it's basically the filter function. Okay, if you still remember, so HS is basically the ratio between the output of a input. Okay, so you need to solve the equation inside the box, then divide the output equation over the input equation, then you will get the transfer function of the filter. All right, so okay, the last part of the Laplace transform usually would be the application of Laplace transform in circuit analysis. So as usual, you need to start with converting the given circuit into S-domain circuit. So you need to transform all components into S-domain function and then solve the circuit by using your knowledge from circuit theory. Okay, and lastly, you need to use inverse Laplace transform to get your equation in T domain. All right, so I'll be sharing more examples of past year's question in PDF files, so please make sure you try them out. Okay, if you have any questions, please drop your question in the Telegram group, so maybe your colleagues can share their opinion, so I'll answer that from time to time. Okay, so with that, I end my lecture session this semester. I wish you all the best of luck, and thank you for your commitment and cooperation throughout this semester. Thank you.